Hello dear students. From this video onwards, we will be learning recursive functions in C. There will be many videos and many examples of recursive functions given in this tutorial because in every GATE exam, there is at least one question on recursion asked for 2 marks. And trust me, once recursion is properly understood with some fundamental examples, it will be very easy for attempting any such question of 2 marks on recursion. First of all, the definition of recursion is a function which calls itself is called recursive function. For instance, the program that I have written here contains a fact function. The name of the function is fact, and you can see in the body of the function, within the body of the function, there is a mention of fact again over here. This shows that when this fact will run, when the fact function will run, then it will call the fact function again. This is the call to the same function. Fact function is calling itself. Then this is recursion. By the way, till now, whatever examples we saw that main function had a call to another function. Like in this example also, main has a call to fact function. Of course, main calls the fact function. But what happens when fact starts running? When this fact starts running, it calls itself. And again fact starts running and it calls itself. This is recursion, isn't it? So now let's see intuition behind recursion and how easy it is to develop a recursive function. Trust me, once you know this, once you go through this explanation, believe, believe it that you will be able to develop any recursive function with absolutely no trouble. So let's see what is development of recursive function. Somebody asks us to write n factorial. Now, how do you define n factorial recursively? N factorial is n into n minus 1 factorial. Everybody knows this math definition. Now, what is the relation of this math definition with recursion? You just see that what are we defining? We are defining n factorial, isn't it? And to find n factorial, we need somebody's factorial. So, factorial takes help of factorial. That's recursion. Fact, fact function takes help of fact function. There is a call to same fact function. Then any such math expression is called recursive expression, or we say it is a recurrence relation. Now, how do you map this? How do you map this in C language? How to write this in C code? It is so straightforward. You want to find n factorial, so you write it as fact function instead of this exclamation symbol. Instead of this exclamation symbol, you write the name of the function is fact. And whose factorial you are finding? You are finding n factorial. So that will become the parameter int n, isn't it? Now what does it do? N factorial is equal to, we have written. Now this equal to becomes return statement. Equal to becomes return, and then this n into n minus 1 factorial will be written here. N into, what will you write? Come on, n into n minus 1 factorial exclamation. This exclamation, how will you write this? You won't write exclamation, of course, but exclamation was written as fact function, so you are finding fact of n minus 1. So fact of int n is going to return n multiplied by fact of n minus 1. Check it out again. Fact of 3, suppose n is 3, will say return 3 into, this n is 3 into fact of 2, correct or not? 3 into 2 factorial. Now comes the interesting part. If you write this fact function just as it is, as I have written, this will go into indefinite recursion. This will go in infinite recursion. How come? You know fact of 3 will result in fact of 2. N minus 1 is 2. Fact of 2 will result in fact of 1. Fact of 1 will result in fact of 0. And height is fact of 0 will result in fact of minus 1. And everybody knows fact of minus 1 is impossible. In fact, recursion should stop. Just check these words very carefully. Recursion should stop. Function should not call itself if n is 0. So we write if n, the parameter n is 0, that means if we are interested in finding 0 factorial, then don't do recursion, but simply return 1. World knows that 0 factorial is 1. So don't do recursion. But if n equal to 0 is false, then put an else. Then put an else. That's it then. This is recursive function, isn't it? And how did we get this recursive function? From the basic math definition. It was so easy, isn't it? If you know basic math definition, you will easily map it in a recursive function. Finally, you just have to write the return type of the function. Everybody knows function must have return type, and return type we will write is long int, because factorial of a number can be a very, very big number. Okay, coming back to this code now. Actually, there is nothing pending. Now you know why we have written this code exactly, why this code has been written. But the way in which I explain recursive functions is I actually show them in execution on paper. Of course, we will execute this function on paper, and trust me, you go through this explanation very patiently, you will have no trouble whatsoever understanding recursive function. Let's try to run this program on paper. Main runs first. It has two variables, int a and long int b. User is asked to enter some number and user enters a number in a. Suppose the value of a entered by the user is, let's say, 3. And we are finding 3 factorial. Then this line everybody knows is a function call. This function call becomes b is equal to fact of 3, because a is 3. So fact function is called by passing n as 3, n is 3. So how are we going to explain this is, I'm literally going to write this function, fact of int n is running. A few things I am just ignoring, like this return type I am not writing here again and again. But fact of int n is running, and what's the parameter here? N is 3. Now you literally run this function. Now inside the function, as you see, there is if n equal to 0. So let's check this condition. Is n 0? False. This is false because n is 3. So if part will not run and else will run. And what is else saying is it should return 3 into, I have substituted the value of n here, return n into fact of n minus 1. So return 3 into fact of 2. N minus 1, 3 minus 1 is 2. So what do you observe now? Take a pause here. What do you observe is fact of n was running where n was 3, and fact of 3 is now about to call fact of 2. This is recursive call. Fact function has called fact function again. So this fact function literally starts running again with n, with this parameter n, no more as 3, but the parameter is 2, because we have passed the value 2 to it. I hope you are following it. So how many functions are actually running? If you can imagine, how many codes are running? Two codes you can think of, loosely you can think like that this fact is running and this fact is also running. But this fact which I am marking is got suspended over here. This is waiting over here for the answer. Listen, this cannot return an answer unless fact of 2 is known, isn't it? So fact of 2 gets busy now. And in this, there is a code if n equal to 0, which is false again because n is 2. So this if part doesn't run and else runs. And in the else, there is a statement return n into, that is 2 into fact of n minus 1. Fact of n minus 1 is fact of 1. So this fact function has a recursive call again. This is the recursive call. So fact of 1 gets called. This is the new instance of fact function where fact of int n, where n is 1, gets executed. So now being n being 1, again if n equal to 0 is going to be false. So else will run, and in else we have return 1 into n into fact of 0, isn't it? But this fact of 0 is again a recursive call. So fact of 0 gets called. Here is the fact function with n as the parameter, but this n being 0. Now starts the fun part. Now we have called this function n with value 0. So if you check the function, check the function code, n equal to 0 is this time true. So the function will return 1. And obviously else will not run, and after that the function will end. That's the body of the function I am writing here. What you see is this function fact. This function fact, is the first function in this series which was able to return some meaningful value. It has returned the value 1, and when a function returns a value, it ends. This function simply ends, but it has returned the value. Take a pause again over here. Function has returned the value. Where does the function return the value? Function returns value always at the call. So from where was this function fact called? Exactly from this point, isn't it? This is the point from where the function was called. So 1 will be returned exactly at this point. This is the point of time where this function, which I am marking, this function will resume its execution, because now it has got the value. Fact 0 is 1, and now it knows, okay, I have to return 1 into 1, 1 into 1, isn't it? And now it comfortably returns 1. And when a function returns a value, it simply ends. So this function ends. I know that the screen is becoming a bit messy, but if you go through it very, very patiently, this is all which is needed. In short, in programming, many times the strikeouts that I am doing is, many times we call it as garbage collection. Anyway, so I am collecting the garbage now because the functions are ending. By the way, where were we were returning 1 into 1, and this value is exactly returned back at the call here. There was a call here, so 1 is returned here, isn't it? And very true, everybody knows in this world that fact of 1 is 1. So we have got correct answer. And now this return statement is going to return 2 into 1. That is 2. And the function will end. This function is scrapped, and the function has returned 2 at its call. Here is 2 returned. Here is 2 returned. Now this function will now return 3 into 2. 3 into 2 is 6, and the function ends. This function ends returning 6, and 6 will be returned back in main. Here 6 will be returned back in main, and the function and the main will print the answer. So this was a very long explanation of recursion, but I hope you have enjoyed it. You have seen how the function gets called again and again, and the functions end in last in first out manner. That's very interesting. The last function, this was the last function, ended first. Second last function ended next, and the very first function ended last. Okay, let's find out, before we come to a close of this discussion. Let's find out another way of working on paper with this function. Because in gate exam, if any question on recursion is asked, you simply can't draw such a big picture and then know, oh, this will be the output. That will take a lot of time. So how do you work on paper and understand what will be the output? Let's say we have again called from main, we have called b is equal to fact of 3. Assume that a is 3. So this is the first call from main. So fact of 3 gets called, and n is 3. So how we show it on the paper is, we show that fact of n is running. Okay, we don't write the return type like int n. It is understood. And this n is 3. The parameter is 3. So we literally read this function, and we understand that when this function fact of 3 will run, n equal to 0 will be false. N equal to 0 is false. So else will run. So we are going to write only that line in our working which is going to run. And we'll say, okay, this function will return 3 into fact of 2. That is n into fact of n minus 1. But then this is a recursive call, isn't it? So we then say, okay, fact of 3 has got suspended, and it has called fact of n, again the same function, with n equal to 2. Now, if you start running this function with n equal to 2, you again run and see that n equal to 0 is false. So else will run, and we will write only that statement which is running. That will be return 2 into fact of 1. So that's the recursive call again. So fact of 1 being called, this function fact of n with n equal to 1 is now running, and again you see n equal to 0 is again false. So else will run, and it says that it will return 1 into fact of 0. but then this is a recursive call. So fact of 0 now gets called, fact of 0 now gets called, n is 0, and now when you run this with n equal to 0, n equal to 0 is true, so the function returns 1. And you know, when a function returns an answer, it simply ends. This function is scrapped. And 1, this value 1, will be returned exactly at the call. So in our working, we can get one value over here, this value, and obviously the previous function will resume saying that, okay, now I can return 1 into 1. 1 into 1 is 1, and this function also will be scrapped, returning 1 successfully over here at the call. Now this function, the caller function, the function which had called, will resume, and it returns 2 into 1. 2 into 1, that is 2, will be returned at its call. Here the call was present, isn't it? And the function will be scrapped. And the calling function will resume, which will return 3 into 2, 3 into 2 being 6, and this function also will be scrapped, and 6 will be returned at the call. Here 6 will be returned, and finally the main will print factorial as 6. So you saw very fundamental of function, how to read a recursive function. You know, you have to become readers of recursive function. By the way, before I end this video, I would like all of you to think recursively. You have to think any problem recursively. Only then you will be able to state the recursive function in C language very comfortably. Lots of videos we are going to see on recursive functions and expertise ourselves in this topic. Thank you very much.